All right, so this is day 2 of our lesson over limits. Pretty much everything you need to know you learned yesterday. I'm just going to remind you of a few things and then just show you some examples that are a little bit more complex. So if you read the top line there, it says we need to know if the function in question is continuous at the indicated x value. All right, so if it is continuous, remember that limit value will equal function value. So there's no difference. You can just plug in that value for x and get your answer. All right, so the first one here, you're looking at the limit of x cubed plus 1 as x approaches -1. What do we know about this function here? It's just a cubic that moves up 1. It's continuous throughout all of x. So all you have to do is just plug in a -1. Because it's continuous, limit value is equal to function value. So just plug in a -1. And let's see, so we would just say -1 cubed plus 1. And we would get 0. All right, on the next one, we do have a rational here, a reciprocal function. We know that there's a vertical asymptote at -5, but notice that the problem is saying what is the limit of this rational, this reciprocal, as x approaches 3? So the question is there any discontinuity at x equals 3? And the answer is no. It's continuous at x equals 3. So we can just plug in 3 and we get 1/8. Again, that's because it's continuous at 3. Example 3, we know the sine graph is continuous throughout all of x. So we can plug in 2 pi. We get 6 pi over 8, which is 3 pi over 4. Sine of 3 pi over 4, if you just picture the unit circle, 3 pi over 4 is right there, where that value is, or that coordinate is negative square root of 2, comma, square root of 2 over 2. I think I said that wrong, but you know what I mean. Negative square root of 2 over 2, comma, square root of 2 over 2. So sine of 3 pi over 4 is square root of 2 over 2. If it's continuous at that x, then it's the same as function value. All right, reminder of all the discontinuity. You have a hole, which is the same as point type. Also the same as removable. I think I misspelled that. That shouldn't have any. Okay, this is also called infinite. Vertical asymptote is infinite discontinuity. And then you have jump. So vertical asymptote and jump discontinuity, neither one of those have a limit value. Where the whole does have a limit value, we say that that's the intended y value. All right, so if you look at the first one, here's an example where we need to factor out and simplify. So I'll take that x squared and I will factor that. So we'll get a x plus 3 times x minus 2 over x plus 3. Here you'll see that those will cross out and you're left with x minus 2. So even though we plug this -3 in down here and it appears that it may be a vertical asymptote, you need to check it and see. All right. So now we know that negative 3, at x equals negative 3, you have a hole because those two binomials crossed out. So now I just plug that negative 3 into x minus 2. So the limit value would be negative 5. You can see in a multiple choice question like this, a lot of people would put does not exist because that appears to be a vertical asymptote. But that is not the case. You have to check and see what type of discontinuity you have. So that one has point type, has a hole. All right, the next one. Here, if I plug a 0 in here, it appears to be a vertical asymptote. But this is a weird one. There's a radical in the problem, so you always want to rationalize something like this. So we haven't seen this in a while, but I'm going to take this and I'm going to multiply by its conjugate. So instead of minus 1, I'll put a plus 1 there. So we'll do that on top and bottom. So when I do that on top, square root times the square root, so that's going to give us just x plus 1 there. Outside is a positive square root, inside is a negative square root, so those will cross out, and then negative 1 times 1 is a negative 1. And then let's see here, down here, I would just multiply that x. Well, actually, I would just leave it out on the outside, and you can see that you'll end up with an x over x times that denominator. So then you would see that these two guys would cross out. So you're actually looking at a hole there. Okay, so the limit of this function here as x approaches 0, need to plug that into the simplified version of all this mess. So when I plug that 0 in right here, I get the square root of 1 is 1, plus 1 is 2. So we end up with the limit being 1/2. Okay? Again, when I plug it in here, I'll get undefined. But the reason there's discontinuity there is because it's a hole, not because of a vertical asymptote. So when there is a hole, you do have a limit value. All right, here's a couple more weird ones. Here we need to simplify this. Right now it appears, we know it's discontinuous at 0. But why is it discontinuous? So let's take that little denominator in that little fraction there, and we'll multiply top and bottom by that. So right there, if I multiply this by x plus 1, that would cross out. Multiply this by x plus 1. And then we'll multiply this by x plus 1. So we get a 1 there, minus, I'm going to distribute that negative 1, so it'll be x minus 1. And then down here, it'll be x times x plus 1. So we end up with a negative x over x. And we end up with negative 1 over x plus 1. Okay? So we have this rational that moves left 1, reflected, but it has a hole at 0. Okay? So now, since we know it's a hole, just plug that 0 in, and you're going to get a negative 1. So the limit value is negative 1. Last one, same concept. If I plug a 0 in, it appears to be, we know it's discontinuous at 0, appears to be an asymptote, but we're going to go ahead and check it out. So distribute that 2. Oh, there it is. I distributed the 2. Minus 2x. You can see these two will cross out. We're left with 2h over h. Those cross out. And you're left with a 2. So there's a hole at h equals 0. So the limit is 2. Like I said, I just wanted to show you just a few crazy ones there. Not too crazy, but you definitely have to use some algebra. But if you flip it over, you'll see your homework on the back. If you look at a few of these, 19 has A through D, so make sure you answer all of those. 20 has A through H. Some of them are function values, some of them are limit values. So just work through all of that. And this will be 8B that I will take up on Monday. All right. Have a good day. If you're taking AP exams, good luck on your AP exams. Proud of you guys. Keep working hard. We're almost done. Have a good one. Bye-bye.